So I mentioned in the last video that in calculus you see a lot of theorems, and in general, one of the main things that is necessary for most of those theorems to be true is that the function needs to be continuous. So we're going to talk a little bit about continuity. So in order for a function to be continuous, you need three things to be satisfied. And actually, this is continuous at a specific point. So if a function is continuous at a point, the first thing that happens is your function is defined at that point. That means no holes, no jumps. We say that f of c is a number. That's basically what f is defined at c actually means. So if you were to evaluate the function, you would actually get a number. Once you have that f of c as a number, in order for the function to be continuous, that number must equal both the left side limit and the right side limit. And as we previously learned in the one-sided limit video, by the way, if your two-sided limits are equal, the limit exists. So that will happen as a consequence of 2 and 3 being true. In other words, basically it's going to be continuous if your limit, your overall limit as x approaches c, you'll notice there's no plus or minus there, is equal to your function value. So this is kind of a summary of all three of these things put together. Continuity is a really abstract concept, so I think the best way to illustrate this is by giving an example. We want to know if this function is continuous at x equals 0 and at x equals 2. We're going to do both of those two things separately. So let's start with x equals 0. In order to figure out if it's continuous at that value, I want you to see if you can on your own find three things. I want you to find f of 0 based on the piecewise function we have above. I want you to see if you can find limit as x approaches 0 from the right-hand side. And I want you to see if you can find the limit as x approaches 0 from the left-hand side. Go ahead, pause the video, give it a try. So I'm wondering how many people might have done this with graphing. You can graph this, by the way. That might be the easiest way for a lot of people to see it. I'm going to actually start off by doing it without graphing, and then I'll show you how to do it by graphing. So first of all, for f of 0, you'll notice I have two parts of this equation where I have x equals 0. The one where f of 0 is defined, however, is going to be in that top equation. So I'm just going to do 0 squared, and that gives me 0. The next one, the limit of f of x as x approaches 0 from the right, that is going to use the second equation. So I am going to be using x plus 1. I get 0 plus 1 is equal to 1. The third part of this, I end up getting the limit as x approaches 0 from the left. That's going to, again, use the top equation. I use 0 squared again, which gives me 0. You will notice that these three things are not equal. In fact, this tells me that the limit as x approaches 0 does not exist. So if your limit does not exist, your function is not going to be continuous. Therefore, this function is not continuous at x equals 0. The second thing that I want you to try is I want you to see if you can do the same thing, but this time you are going to do it at x equals 2. Try it on your own. Okay, so f of 2, again, we're going to use, in this case, we're using the bottom two equations, and f of 2 is going to use this one right here because we have that x is greater than or equal to 2, so you have that or equal to right there. So we're going to do 5 minus 2, which gives me 3. Now we're going to find the limit as x approaches 2 from the right-hand side. That's the same equation that I just used. That's where I'm greater than 2. So again, 5 minus 2 is equal to 3. That's a good sign so far. These two are equal. The last thing I'm going to do is I am going to find the limit from the left-hand side. In that case, I'm going to use this one in blue. I'll actually change to blue color. So I am going to use x plus 1 as my equation. That's going to give me 2 plus 1. Again, that's also 3. If all three of these things are equal, then that is a sign that your function is continuous at that value. So it is continuous at x equals 2. And I think it's really helpful for this type of problem to solve it to draw a graph at least. You don't have to necessarily solve it by graphing, but having a graph is helpful to look at. So this is what the function looks like. I want you to notice, based on this graph, it does actually match with the problem that we just did, the way that we did it. You will find that f of 0 is equal to 0, which we notice there. You also will notice that the limit as x approaches 0 from the left is equal to 0, but the limit of f of x as x approaches 0 from the right is going to be equal to 1. You can see from the graph that it obviously doesn't look continuous because it jumps from one place to another. Now, at x equals 2, on the other hand, it does look continuous. I made the point like it looks like it's coming out of the peak, but you didn't even need to draw that point. You will see from this graph that f of 2 is equal to the limit from both sides, which is good. That's what we want in order for this function to be continuous. So because all three of those things are equal, that means the function is continuous at x equals 2.